Yeah, today we want to learn a little bit more about NumPy and Matplotlib. So basically, it's an introduction to NumPy. What's NumPy? Basically, it's an open source Python library designed for specific numeric computation. It is also a tool to perform linear algebraic Fourier transformation, generative random number, and it can be written in C, therefore execute very quickly. NumPy's array are an additional data type provided by NumPy. They are also used to represent vectors and matrices. NumPy's arrays bear some resemblance to Python list data structure. NumPy arrays are homogeneous and type array of kind of fixed. Homogeneous means that all elements in the array have the same data fixed, that an array cannot be resized without creating a new kind of new array. Yeah. So with that, okay. So NumPy array has a size that is fixed at time when it's constructed. Element in NumPy array are all the same data types and leads to efficient and simpler code. These elements are float points. The module is imported as follows: import NumPy as NP, where 0 underscore vectors is np.05. This means that the first argument in the tablet 5 tree specifies the number of rows and matrices. 0 matrix equals to np0 5-3, meaning the second argument, which is a 3, specify the number of columns in the matrix. So basically, this is how it actually works. The NumPy array object, the core of the NumPy library, is structured for representing multi-dimensional arrays of homogeneous data. The data structure for M arrays in NumPy is ndarray class. It also contains important metadata about the array, such as shapes, size, data, and other attribute shapes, size, which is a dimension ndim, and bytes is the number of bytes stored in the data, and d type is the what type of data is in the array. So example of a NumPy array object is, for example, you input a data is equals to a NumPy array 2, 4, 6, 8, 10, 12. So in the type of data, the output can be NumPy or kind of a ND array. So in data, out array could be 2, 4, 6, 8, 10, 12. So in, you can put dimension and out is 2, then the data that shape out is 3, 2, and in data shape and out can be 6. So this is basically one of the way to look at the data structure. And the data type, int basically is integers, uint is unsigned non-negative integer, uint, bol is boolean, float is a floating number. It can be float 16, float 32, float 64, float 128. Complex is a complex value floating numbers. So it is adopted from the numerical Python of an approach. So a NumPy array, as mentioned, lowercase variables are vectors of one-dimensional array. Higher case variables are metrics of two-dimensional arrays. So input x can be a NumPy array 1, 3, 5, and input y can be also a NumPy array 2, 4, 6, where input can be x plus y. So you can try. A can be a NumPy array x plus y. Then basically what you comes out with is out, where the array, like the first part x, y, z, x could be 1 plus 2 is 3, and y part would be 3, 4, can be 7, 5 plus 6, 11. Yeah. So data type example. So in NumPy array 1, 2, 3 data type for integer, that output array is 1, 2, 3. The NumPy array 1, 2, 3, and the NumPy type can be a NumPy NP float. So output can be 1 dot, 2 dot, and 3 dot. So it can be output of this way. So in at line number 12, you can put NP array 1, 2, 3. a d type dot np complex, and out of array can be 1 dot plus o dot j, because there's complex numbers behind, and 3 dot plus o dot j. So in 22 we can have an input of d1 can be a NumPy array of 1 2 3 and float, and the type can be a float type, and it also can be a NumPy array of 1 2 3 and float can be a complex. So in short, it can be a d plus 1, and out can be 2 plus 0j plus 4 plus 0j plus 6 plus 0j. So that could be an output array, and input can be d1 plus d2, and the data type can be a complex number of 128. Yeah, so this is a data type example. Complex number can also have different parts, where np square root np array -101, runtime warning where invalid encountered in square, array where it can be none, dot 0 and 1 dot. In np square and array can be -101, data type can be complex, and out can be 0 plus a complex number 1j plus 0 plus 0j plus 1 plus j, and input could be a np array 2 4 6, and then you can output it. So when you actually could add these two up together, it can become an output array of 2 plus a complex number 0j plus 4 plus 0j and 6 plus 0j. So that could be the part, and then the real data can be 2 4 6, and the imaginary data can be 0 0 0, so that it can actually split into two parts. Yeah. So in summary, NumPy function for generating array, np array, creates array which the element are given like a array type, for which example can be a nested NumPy, tuple, irritable sequence, or another ND array instance. np0 could create an array with a specific dimension and data type that is filled with zeros. np1, there is an array that is a specific dimension and data type is filled with 1. So np diagonal, yeah, can be specified along the diagonal where zeros are anywhere else, and np arrange can create arrays with evenly spread value between specific starts and incremental values. So sliding the NumPy array is easier to slice the index of a NumPy array regardless where they are vectors or matrices. One-dimensional arrays and index to be given to the element is given by the position, but you can bear in mind that the indices start with 0. So two-dimensional array, the first index specified the row, yeah, and the array of the second index usually specify the column. So remember indexing logics, starting index includes but stop index is not included. Therefore, Python stops before it hits the stop index. So indexing for slicing expression, can put a bracket of m, which means that it selects the element at the index m, where m is an integer counting from 0, where a bracket minus m is the select of the n element from the end of the list. So you count backward, where m is an integer and the last element in the list is addressed as s minus 1, second to the last element as minus 2, and so on. And then m bracket n colon n is selected where the index starting from m and ending m minus 1, m and n are integers. So n colon or n colon minus 1 or other element given the axis, and a colon n is the selected elements starting with the index 0 going up to the index integer. So m colon or minus 1 is the element that's starting from the index m and integer going to the last element in the array, where a, m, n, p is the selected element with index going through with n exclusive with incremental p. So p becomes incremental, and you will have a bracket colon minus 1 is select all element in reverse order. So this is some of the slicing expression. So citing index could be, for example, NP array 1, 2, 3, 4, 5, 6. Y NP array could be 2, 4, 6, 8, 10, 12. So where your input is x2, where your x can be 0, 2, output array can be 1, 2, 3, 4, 5, 6, right? And then can then try x colon 2. So using the character of NumPy array with the dimensional arrange the use of the characters in place, fixed, and index result that the array elements correspond to all values that particular index will be returned. For 2D array using just one index returns the given row and inner row that corresponds to the row that will be returned. So x equals to NP array 11, 12, 13, and NP y with an NP array of 3, 4, 6, NP array 11, 12, 13, 3, 4, 6. Input could be 2, output could be 13. Yeah. So and then when you have input x 0, 1, that means your output is basically 11, 12, 13, starting from row 0 and end at row 0. This is how you can actually read it. Yeah. So with that, so you have an input of z, which is x plus y, and integer of z could be the array of x plus y, right? So your x is 11, 12, 13, your y is 3, 4, 6, then you plus this together, could be a 14, 16, 19. Yeah, so this is how we actually can look at the NumPy array. So with that, using the character of NumPy array, it can actually has a x equals to NumPy array 11, 12, 13, 3, 4, 6. So you can see that 0, 0 is actually 11, and y of NumPy array 2, 4, 6, 10, 8, 12, where x common 1, which is output array common 1, right, which is start from the first column, which is becoming 12 and 4, right? So this is how the output can be like given. So when you have a x which is 1 common 1, which is still the second column because it's first the what column 1, right, which is the second column, plus y at comma 1 which is still the second column. So you have 12 plus 4 give you 16, and 4 plus 10 give you 14. So this is how we actually can look in the input. If you're given that x is actually at 1, so the array at 1, right, could be is x, right? So 1 will be 3, 4, 6. So if you look at this input of x at 1, given that the column is kind of a 0 and then y is 1, then the array output becomes the first row at 3, 4, 6 plus basically 8, 10, and 12, right? So it becomes 3 plus 8, which is 11, and 4 plus 10 is 14, 16 plus 12 is 18. So this is how we can actually do the array. And of course, you can have NP array 2, 4 plus NP array 6, 4, and this could give you 6, 8. So 2 plus 6 is 8, and 4 plus 8 is 12. Yeah. So with that, indexing of NumPy array can be indexing with other arrays such as sequence like object. So when your input is Z1, NumPy array could be 1, 3, 5, 7, 9, and Z1, and then output, right, will be 1, 3, 5, 7, 9. So because it display everything as output, but Z2, if you have a plus 1, then the whole matrix can actually plus 1. And input of integer 0, 1, 2, right? 0, 1, 2 meaning first row, second row, and third row. Integers out of Z1 could be the first, second, and third, which is 0, 1, 2 rows, right? Column. So the integer are NumPy 0, 2, 3, and the integer becomes, where's 0? 0 is actually 0 row is 1, 2 is 0, 1, 2, which is become 5, 3 is 0, 1, 2, 3, which is 7. So the output array could be 1, 5, 7. So indexing NumPy array using logics. So we can also use a logic to actually arrange NumPy. The input of Z1 could be NP array 13579, and you can use like Z1 is greater than Z. The output will be, you see, 1, 3, 5. These are less than Z, right? So it becomes false and false. And then the 7 and 9, which becomes true, which is greater than 6, right? So this is a Boolean type of information, yeah. So using the Boolean array, it can also be a logical array to another vector, which the integer of Z1 that is greater than 5, so meaning to say that output greater than 5 is actually 7 and 9. Okay, so Z2, 7 and 6, then output could be 8 and 10 greater than 6. So the integer of 7 greater than 7, and integer can be becomes a false, 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 and true because it's greater than 6. Then it becomes true. So the data type becomes a Boolean output. And the integer of Z1, the output array will be 7 and 9, and the Z2, right? Z2 is greater than 6, could be 8 and 10. So yeah, this is one of the ways that we can actually index the NumPy array using a logic. So indexing NumPy array, integer U1 is equal to NP array 1, 2, 2, 4, 6, 8, 10, and W could be U1 0, 3. 0, 3 means what? The first column and the third, right? So where's the third? 0, 1, 2, 3, so it becomes 8. So W, the output array from 0 to 3, so it could be 1, 2, 3. So 2, 4, 6 will be that. And then if your input is at W where it's equals to 3, your output can be actually blank, and U1, the array will be 3, 4, 6, 8, and 10. So this is by indexing the NumPy array. So NumPy reshape function, you can reshape the function given a shape function to a array without changing its data. So importing NumPy as NumPy x np.array 1, 2, 3, 4, 5, 6. Then your np reshape could be x 3, 2, where the output could be 1, 2, 3, and 3, 4, right, and 5, 6. So you actually you reshape the array. That's one of the way.